Today we're going to be putting together the LASK4 version 2. The LASK system stands for Label Seeking System, and it applies the label data to the machine data that we're putting into an artificial neural network to solve the prosthetic sensor problem. I know I've talked about this in my other videos, but I have a coffee tin of these. These are my favorite board. If you haven't seen it yet, please check out my video, 5 Reasons Why to Use an ESP32S2 in your next electronics project. These things are pretty versatile. In essence, they have 32 pins on them, 27 pulse width modulated, 16 ADCs, 10 of them are touch pins, and 2 of them are DACs. So this board pretty much has enough pins for you to do whatever you could think of, and at only $2, you can't really ask for anything better. Again, I also say in that video I didn't cover it, but if you do try to have this be a wireless access point, you might run into memory issues, because these come with 4 megabytes of flash and 2 megabytes of PSRAM, SPI RAM. I can never get that one right, so yeah, correct me in the chat. So now that I have all the components, I can start putting everything together. As you can see, the main microcontroller, along with a slot for the power charging unit, for the buttons, the screen, the power on and off, and of course, most importantly, the Hall effect sensors at the top. How this module works is that the 4 Hall effect sensors at the top are placed directly below the pistons of this spring system. This spring system is actually a musician's device that's used also for physical therapy to strengthen your fingers for people that play instruments, but I've adapted it to actually just be a finger motion detector. But it doesn't just detect motion, it actually detects force. By knowing the value of the springs, you can also calculate the amount of force required to push the pistons in. Another useful thing about this system is that when you push the pistons in, you have to flex those muscles in your forearm a little bit greater if you have more force to push. I'm trying to compartmentalize this very big problem into small bite-sized solutions, or small problems that I can find potential solutions for. This device is often called a somatosensory device, which I don't like that term necessarily. I think it has to do with the sensing part of your brain, because you have the motor cortex, which is right next to the somatosensory cortex. But that might make sense, so I guess you could call this a somatosensory device. I just call it the LASK system. And LASK, of course, stands for label seeking. It applies the label data to the feature data that I get from Open Muscle. And I do believe with an artificial neural network, this problem can be solved quite simply. It's just a matter of how much data we can get. Now, biometric data is very difficult to get, or it's rather expensive. So my hope and dream for this system in its entirety is to actually supply biometric data for the industry. Because if we have enough biometric data, we can use a myriad of different types of sensors to solve the problem. There are some other companies I have my eye on. The biggest one is Ultimate Robotics that produced the U-Myo bracelet, and I'll be showing tutorials on how to get that up and running alongside this LASK system. And again, the Gerber files are located online. You can download them and make them. And I even have a Discord if you guys are so inclined to help or whatever. Right now it's just myself, so I have an open invitation to anyone else who wants to continue alongside me to try to help others, to see if we can make a positive dent in this world. So you saw me put together, or at least solder, the components. After we soldered this all together, and we were able to swap out the old board, the version 1 board, with the new board, we can go ahead and see it in all of its glory. It looks like it boots up just fine. Perfect. And we can see its menu. Let's test to see if the pistons can detect it. Yes, and these pistons are they're just made to fit onto the Diodario device that I purchased online. The device can be purchased for about $15 on Amazon. I don't know the cost of the PLA, but it's pretty close to negligible. I'm using 5mm diameter magnets, Hall effect sensors, ESP32S2, charging circuit, and screen. So it's about $2, $4, $5. It ends up being not that expensive, maybe about $15. I need to put together a price sheet for you guys, but this is the LASK4 version 2, and it's going to be training Open Muscle to see how good the deep artificial neural network can be for a system that actually just uses Hall sensors and magnets to detect the topology of the forearm. So since there's only 4 sensors on here and the data is going to be very, very clean, that's what I needed. I needed the label data to be clean to start some of the next processes. Also, I can start and stop the data acquisition from these buttons, because how the open muscle band is that it is kind of headless. This one does have another screen on it, but it's sending packets over UDP. This is also sending packets over UDP, and I'm collecting the data on a main computer. It's being able to send at 1,200 samples per second. I appreciate you guys joining me today. Follow, like, and subscribe. I'll be posting videos soon of all the progress that I make as soon as humanly possible. I do enjoy this stuff, and as always, let's see if we can make a positive dent in this world.